Okay, in this predict the product question, start with an alkene, treat it with MCPBA, which makes the epoxide, and in the presence of acid and ethanol, the epoxide is opened up as ethanol adds. And so what we going to end up getting is a molecule with an OH and an OET group on adjacent carbons. Now, since we're so when we do this reaction, first thing that happens is the epoxide forms. Okay, I'm going to put it like that. It's kind of a placeholder. And then the ethanol is going to add. Now, since we're under acidic conditions, the attack is going to go on the more substituted side. So the OET ends up on the more substituted side. And so that would be this side right there. So I'm going to go ahead and erase the bond, the epoxide. I'm going to put the OH on the less substitute side. And then I'm going to draw in the OET. On the more substituted side. Now, let's worry about stereochemistry. If the OH is a wedge, that means the OET must be a dash because these conditions add net anti to each other. Now, you could draw it like this. If you do, if this OET is dash, that means this ethyl group is a wedge. Or the other possibility, you could have drawn it. The OH is a wedge. If you drew your OET up here, then you make that OET a dash, and then therefore that methyl group is a wedge. These two molecules are the same molecule. To kind of prove that to you, 1, 2, 3. That's an S chiral center. 1, 2, 3. That's an R chiral center. 1, 2, 3. That's an S chiral center. 1, 2, 3. It's a little harder to do. That's an R chiral center. SR, SR, doesn't matter. Okay. Also, since we're going from an achiral starting material to a chiral starting material, the product is going to be racemic. What that means is this OH could have been a dash, and then that OET would be a wedge. So in that case, instead of the SR chiral center, you'd have an RS. So our answers are going to have the two chiral centers like this. Well, let's take a look. Now if we take a look at choices B and D, we can rule those out because the OET group is on the less substitute side instead of the more substitute side. So, you got to look back at A and C. And now it's just a matter of figuring out R's and S's. 1, 2, 3. That's an S chiral center. 1, 2, 3. That's an R chiral center, so that checks out. Let's check out the next one. 1, 2, 3. That's an R chiral center. 1, 2, 3. That's also an R chiral center. That's the wrong one. Wrong diastereomer. So the answer is A.